All right, so we are going to interpret this exponential graph. This is the practice quiz from 4-12 to help you with the quiz from 4-14 to boost this learning target grade. All right, so to start, what we're going to do is I'm just going to go ahead and highlight some important features, some text features on our graph. So I'm going to go ahead and highlight the title. Right, that's going to give us some help to understand what this is about. I'm also going to go ahead and highlight these names on the right side. So that's what each line represents. So you'll want to pay attention to the color of each line. And then I'm going to go ahead and highlight the x-axis and then highlight the y-axis. All right, so these are some important features I know that I'm going to be looking at. I'm also going to go ahead and just label them myself. They're not labeled here, but it's obvious that these are going to be years, and this is going to be population. Okay. So the first thing we want to look at is the domain and range of this function. All right, so we're going to look at the domain is going to be the same for every single line that we have here because they all extend across the same points on the x-axis. And then the range will have to focus on a specific line. So for the domain, I'm going to go ahead and look at my x-axis and say, all right, we start in 1800. So we're going to be from 1800. There we go. That's a horrible 8. And we go all the way, every single line goes all the way until 2019. Okay, so for this you can use your x-axis, or most of the time it will be in your title. If it's not in your title, you can always go to the x-axis, but it's most likely going to be in your title, x-axis or in your title. Okay, those are the two different spots you can always look for it. Next, true or false, 500 million is a data point in the range for Indonesia, right? So at this point, I'm only focusing on this green line with Indonesia, right? I can only focus on this line for Indonesia. Okay. So true or false, 500 million is a data point in the range. So remember, our range is always going to be along our y-axis. So I want to see if that green line that I just highlighted ever gets up to 500 million. So what I'm going to do is just mark off 500 million where I think it is. And this would be about 500 million. So you can take that all the way across. This is going to be 500 mil, right? Now, if we look here, we can see that our green line never gets up to 500 million. Right, so that is going to tell us that that is false. That statement is false. 500 million is not a data point in our range because the population of Indonesia has not yet gone up to 500 million people. All right. Next up, we are going to figure out the rate of change for this graph, right? So for all of these, it's going to be the same, but specifically, we're going to go ahead and just look at India because it has the best representation of population growth. All right, so we're going to focus on this India line specifically here. All right, all of them have the same trend, but that one just has the best shape for what we want. So what is the rate of change for this graph? First of all, you want to ask yourself, am I increasing or am I decreasing? All of these graphs are increasing, so we can automatically get rid of anything that has to do with decreasing or decay. Okay, because we know that our graph is always going to be increasing, looking at it, we know that it cannot be decreasing or have a decay rate. Right? The next thing we want to look at is, does our graph shoot up really fast at any point, or does it stay in a consistent line as we look at it? All right, so if we're looking at this, increasing by the same amount means a consistent line. And then growth rate is going to be, there's going to be a jump in it. So it's going to look like that. All right, so looking at our graph, it's not a straight line, so it can't possibly increase by the same amount each time. It would have to be a straight line if it was increasing by the same amount every single time. So that leaves us with our growth rate, and that is our answer. Our growth rate becomes more rapid over time. Okay, so I'm also just going to highlight that. Growth rate becomes more rapid over time. And for our exponential functions, your options are only ever going to be growth rate or decay rate. You will never be able to put increasing or decreasing by the same amount, because an exponential function is, the definition of that is going to be a growth rate or a decay rate. So it can never increase or decrease by the same amount. All right, next up, we want to explain the point 2019, 328.2 million for the United States in the context of this problem. All right, so again, I'm just going to go ahead and highlight the line that I'm talking about. We're talking about the United States here. So I'm just going to highlight that so I don't forget. The United States. I'm also going to go ahead and locate that point on the graph. So that point is right here, 2019, comma, 328.2 mil. Okay. So I want to understand what that means in terms of the x-axis and in terms of the y-axis. So we already labeled earlier that the x-axis represents the years, right? And the y-axis represents the population. So I'm going to go ahead and take my first point, 2019, and say in the year 2019, because that's what it means. And now I'm going to talk about the y-axis, what that y value means, what the y-axis means. So in the year 2019, the United States, because that's the country we're talking about, had a population, because that's the y value, that's what the y value represents, of 328.2 million people. Okay, in the year 2019, the United States had a population of 328.2 million people. So you want to make sure you're mentioning both your x-axis and your y-axis when you are explaining the point in context. And you also want to make sure that you include both of your numbers in your sentence. Okay, so both points, both values, the x value and the y value. All right, and then finally explain what is happening in this graph for India. All right, so there's a lot of different answers you can have here. The key here is that the graph is increasing exponentially, or the growth rate becomes more rapid over time. So that's going to be in relation to our rate of change. So this is going to be the graph for India. And remember, we are focusing on that red line that I highlighted earlier. The graph for India is increasing or growing at an extreme rate. Okay. Something else you can note is just any special points along the graph. So the population starts increasing rapidly at 1950, or not at, I'm going to put in 1950. Okay, because if we look here, around 1950, that's when we really have a big jump. So the population starts increasing rapidly in 1950. Right. and any other way you can describe it. So anything you can think of, you can add that there as well. Part 2 of that is going to be, why do you think this graph is shaped the way that it is? So there are a lot of different thoughts here. So we can say that population is always growing. Some thoughts I had from students are that medicine got better in the 1950s, so people could stay alive longer. Okay. So for any diseases that might have knocked people out in the late 1800s, early 1900s, medicines were developed so that they could stay alive longer, and thus the population kept getting bigger. But anything you can think of that would cause a population to grow is what you can put here. It's really just your opinion, what you think could happen. There's no right or wrong answer. It's really just whatever you think could possibly happen. All right. And then you always just want to think about what would happen in the next 10 years. Are we going to continue to increase? Most likely our population will continue to increase as time goes on. We get more materials, we can sustain our lives longer, so the population will continue to grow.